Okay, so let's get it started. Hi, my name is Kengo Suzuki, and welcome to my session, the deep dive to FIDO.fido2. I work as security engineer in one security company, and so you may be interested in why I'm giving this talk in terms of Android. So today I'm going to go over FIDO, but first let me express my motivation talking about this FIDO. Okay. So the FIDO in terms of Android, I gave a presentation last year, back in 2018 February. At that time, only v1.1 was out. Well, v2.0 was on the document, but was not in the real world yet. So what I'm trying to say is it has changed since last February. Okay. So 1 month after I gave a presentation in 2018, the WebAuthN has came out, which is a spec came out from W3C, published W3C. So WebAuthN is basically an API for creating and generating PKI-based credentials, which is a big part of FIDO 2.0. So the big movement of FIDO 2.0 started in the last March. And since then, many browser vendor implements that API. So developer can hit that API to create credential in very secure manner and very convenient way. So how about FIDO 2 movement in Android? It actually occurs on the last May, and gms.fido.fido2 has came out. So within 365 days, there are a lot of changes. I mean, in terms of the FIDO presentation I gave last year, it's already outdated. So I decided to give a talk about FIDO 2 in Android again. So today's goal is the following. So when you walk outside of this room, you have a sort of understand FIDO 2 and understand how you need to implement that in Android using the FIDO packages. So here is the overview of FIDO. How many of you know the FIDO, the existence of FIDO? Anyone read the specs? Okay. Well, anyway, so since not all of people know about FIDO in terms of its not the spec but its existence, and let me give a short overview of it. Okay, FIDO is abbreviation of Fast Identity Online, which is Alliance itself, and then protocol which Alliance defines as well. What is that protocol? It's scalable and interoperable and anti-phishing type of authentication protocol, which comes down to the elimination of password as credential. Now, why do you want to eliminate the password? Let's take a look at some numbers. Okay, so this article is actually, let me just summarize it. Okay, so most of the user knows the danger behind the password. Most of people know using the password is bad, but they still do it anyway for the convenience reason, because they want to know and be in control of the password. So it's like this. So rephrasing it, they are aware of the fires surrounding you, but hoping for optimistic outcome, which is not, obviously. So, so how does a breach of the password occur? One vector is phishing. One vector is interception of the traffic. And lastly, one reusing of password and site, the website which leaked the password can be another vector. You may ask, how about 2FA? Doesn't it give better password experience? I would say it's better than nothing, but not entirely good enough. So some 2FA is replayable. The problem of 2FA is it's replayable. So, and it's still not the it's still vulnerable to phishing attack. So imagine you prepare the phishing site, including the password input and the TOTP input. The user is still deceived that page is legitimate site. So even it's 2FA, that victim is going to put both password and TOTP. So then that means attacker can gain both of that credential, which actually means nothing. And same for the push notification. And there's actually a case that 2FA got compromised. For example, when you use the SMS type of 2FA, the card itself got swapped, or actually 3 days before this, the English bank has announced that their SMS protocol has vulnerability and that protocol is hacked. And also, there was a case where someone made a phishing site of the Binance, the cryptocurrency trading company, and then some users got their cryptocurrency stolen. So there is actually real cases here. So what I want to say is, as long as it relies on the human, like inputting both passwords and TOTP or push notification to human, there's a vulnerability. So FIDO or FIDO2 is trying to address these problems by breaking down the authentication responsibility not only to server but also to the client. Also, FIDO2 is binding the credential to origin, which prevents a phishing attack. And then also it customizes challenge and response to make 2FA by default and less involving human operation. Okay, so let's take a look at general FIDO model. In current situation, in current password experience, the server has all the responsibility. So it has it's responsible to store the credential, responsible to verify authentication, and responsible to identify the user. So all those functionalities concentrated on the server side. Then FIDO protocol separates that responsibility between the server and Android device or whatever platform, and additional elements called the authenticator. So the server service provider, which authenticates user, is called relying party, and the client side is called client anyway, and the new element called authenticator, this is where it generates and stores the credentials and actually identify user over here. So it breaks down the responsibility. So this is actually the thing. So authenticator verifies user and store credential. and server side verify the result and identify user. And this key shown here is bound to the origin, and so that it protects from phishing attack. So you need to register. So I said the authenticator generates a credential. So there is a step to register this credential to the server. In FIDO term, it's called attestation. So for this general step is it involves a lot of communication with server and client side. So first, the server send a challenge along with options that you can use in credential. Then authenticator uses that option to create credential, and along with user authentication. By doing so, authenticator generates a credential key pair, which is called assertion keys, and store the private key side in the secure storage, and then sends a public key with signed challenge response back to the server. And then server verifies the credential information and stores the public key. So this is how you register your key pair on both client and server side. How do you use that credential to authenticate user? In FIDO term, it's called attestation. Oh, sorry, assertion. This is typo. It's called assertion. Okay. Again, it's very similar flow. Server sends the authentication option, and then authenticator verify who the user is, and then internally authenticator signs the authentication results and sends back that result along with the credential information to the server. Then server checks signature and verifies authentication. So as you can see, it's by default two-factor authentication. So first you verify the user on the device side, and then verify the result of the, not authentication itself, but verifies the result of the authentication process on the server side. So it's 2FA, but there's much less human involvement. It's all occurs in authenticator side and server side. Thus, it protects vulnerability that human has. But this is not only it. You actually want to know the key stored in the server side is the correct one. By what I mean by correct one is that whether the public key is generated in the secure manner. Is the key not swapped during the registration process? Basically, to answer those questions, you need to know who sends the public key, and that process is called attestation. So in law side, attestation is something to confirm or authenticate the something. Well, in origin, it was about witnessing, but when it comes to FIDO, it is the process to check the provenance of an authenticator and the credential keys that it generated. So now I'm going to talk about how this attestation can be done in Android side. Actually, there are two ways. First way is called Android key attestation, which came on the Nougat. What it does is it prepares the key pair before it's shipped from the manufacturer. So the key pair is generated within the factory and burned into Android device before the shipment. And that key, or private key, signs the user's public key so that server side can testify whether it is generated within the legit device. So this is code. So you actually just need to specify one line when you generate the key pair in the key store. It's called a set attestation challenge. And then when you generate the key pair using that and extract the certificate, you will see the root certificate is just like this. This is the root certificate I generated in my Pixel 3. So the root certificate has subject CN command name Android key store key, so saying it's generated in the key store. And also it has the extension, the OID 1.3.6. whatever, and it is basically says it's key attestation. It was generated by the key attestation way. So by checking the certificate on the server side, you know the key, the public key used for the authentication is generated in the secure way. Okay, so that's one way. However, as I said, there are some devices not implementing that key attestation feature. In that case, you can use a safety net attestation API. This is not really telling you the key is generated on the key store, but it checks the device integrity of your device using metadata from hardware and software by checking against the testing suite called the CTS. When it's successful, it sends back the result in JWS format, and it contains this type of structure. The server side checks this CTS profile match, and when it is true, then you can say that attestation is done in the secure manner. All I'm saying is that they are on the FIDO2 spec, so it's not something limited to Android. But there are some drawbacks in safety net attestation API. As I said, it only checks device integrity, so not really like attesting it. It's just checking whether the device is not jailbroken or became unsecure manner. And also it requires to access the Google backend. That means we do not really know the logic how Google says, okay, your device is not secure or secure. Also, there are some limitations when you call that API. So it's generally a good idea to use Android key attestation when it's available. Okay. All right. So that's pretty much it for the overview of FIDO. Now we are getting into the implementation of FIDO2 in Android side. So from now on, I will talk mainly about the Google's package called com.google.android.gms packages. It contains several packages, directories, and it has a .common, .fido2. That's all you need to know. There are some internal packages but you won't be able to call from your app. It's done internally. And the good news is that you do not need to define or implement FIDO2 by yourself from scratch if you use this packages. .fido package has already took care of the hard part, like generating key pair, storing it in secure manner, and assign the attestation result, or making the UI so that user can interact with it. All of that is done within the packages, so you don't need to worry about it. Only you need to worry about is how to use this API and understand the parameters you're going to use for these packages. So what I talked previously, the key attestation and safety net attestation, and biometric prompt, you don't need to care. So when I found out, I was kind of realized that I did something wrong when in the CP call for the paper, because it says I will talk the difference of the package and this. So there aren't any difference, but you don't need to worry about it. Okay, so let's get into the main part. So how do you register the public the key pair using the FIDO2 packages? Let's take a look along with the actual attestation and assertion flow defined in the spec. So first, you are going to get the options from server, like what parameters you can use when you create the credentials. Then you generate credential by calling the FIDO2 API. After the internal system creates credential and gives you back the result, then you send that result to server. That's all you need to do. So now on, I will show the actual code along with FIDO2 or WebAuthN specs. When I was making these slides, I found that they are kind of difficult to see. So I prepared one short manual how you are going to look my slides. So from now on, the upper part describes specs in FIDO2 and WebAuthN, and the bottom half is about Android implementation. Okay, so let's get into it. The get option, where you're going to ask what parameters can be used when you generate the credentials. That option is called server public key credential creation option. It has 4 fields. 2 required fields are very self-explanatory, username and display name, so I won't talk this much, but instead focus on the 2 fields described here. So that they are authenticator selection criteria and attestation conveyance preference. Luckily, you do not need to define those 2 parameters. As I said, .fido package already prepared the blueprints for it. You only need to put the parameters and define the instance for it. So authenticator selection is basically tells what attributes of authenticator needs to have when you generate the credential. There are 3 fields, but 2 of it is not available in the FIDO packages, so I will only talk one of it, which is authenticator attachment. Authenticator attachment specify the form of authenticator, and they are either platform or cross-platform. The platform means authenticator is attached to the platform itself. So, for example, in Android case, the platform will be the authenticator, like fingerprint and the key store. That's because it's attached to the platform itself. Comparing to it, cross-platform is something detached from the platform. For example, it's going to be like YubiKey. So YubiKey NFC or Type-C insertment type, whatever, which is anyway, it's detached from cross-platform. So if the service provider or relying party wants authenticator which is not relying on fingerprints on Android, you can specify cross-platform here. And the second parameter I'm going to talk about is attestation conveyance preference. This is enum with 3 values: none, direct, indirect. They essentially describe whether if you want the attestation whether if you want the attestation in the registration process at all. So if you specify none, that means you're not interested in attestation at all. And if you specify indirect, you are kind of interested in attestation, but it allows you to override the attestation. So that means the client side can make their attestation statement and then overrides it. And direct is most strict one. It means, okay, I'm not like trusting the client side at all. It only trusts what it came out from the authenticator itself. So that's the option request form. Now, let's say the server successfully received and responded to that option request. Then the next step is to pass that option to generate the credential. And when you pass that option, you need to define this interface called the credential creation options. And again, FIDO2 packages prepare all that stuff for you. You only need to define the public key credential creation options and call the builder for it and fields methods by yourself. So first, let's talk about this guy. The set RP is you're going to set the information about the service provider or relying party. It contains ID and the name of the relying party, and if you're interested, you can include the icon, a URL. So for example, the RP ID is essentially the origin of server side. So if you are interested in, if you want the relying party to log in, you can set the domain, FQDN with subdomain. Like login.example.com will allow user to log into login.example.com and example.com. And then set user. This is another very self-explanatory field, but it's defining the user itself. Now the set challenge and set challenge. Again, FIDO prevents phishing attack by challenge and response authentication. So by setting this challenge, authenticator knows the challenge, and when it returns the credential information, it returns a challenge in a secure way, meaning I will talk about that later. In the timeout means it defines how long that authentication can last. Then set parameters. It is the parameters to define the public key you're going to generate. So what that parameter is going to be the essentially the algorithm itself. You see the public key creation credential type, but it's a type, but it's actually the static value, which only has a public dash key. So you only need to worry about algorithm at this point. So FIDO2 packages allow you to specify two types of algorithm. One is elliptic curve, one is RSA. But in WebAuthN, generally elliptic curve is recommended one. Okay. Now set exclusion list. This parameter is to prevent double registration of authenticator. You want authenticator that is tied to the user should be one. If that's like tied to two people, then you cannot make a difference between the users. Okay. So exclusion list is tells authenticator what credential you're not interested in at this point. So it defines credential ID and authenticator transport. At this point, I wouldn't talk so much about authenticator transport because I could not understand the use of it. Well, anyway, so the credential ID is set to the public key credential descriptor, defining, okay, check this credential ID, and if that credential ID is within your authenticator, don't do anything at all. So that's what it's defining over here. And lastly, it has a field set authentication selection criteria. But this one I already talked in the option request part. So again, this is describing attributes of authenticator, and server side is whether it's interested on the authenticator that is attached to a platform or not. Then lastly, there's a set attestation conveyance preference. Attestation preference, this one is the same one I already talked in the option. So it has three values: direct or indirect or not. If you set direct, you want your attestation in most strict way. So the attestation information should only come from the authenticator itself. Other two parameters, you're not too strict about it. Okay. So options is built. Now you're ready to generate the credentials. But you're not the one who is going to generate the credential. The internal system does. So what you only need to know is how to call the internal system and pass options you created. So how do you do it? So if you're an Android developer, you're very familiar with, you should be familiar with this concept, but it is essentially generates an intent and launch that intent to call the internal activity. So there is a dedicated intent for it. It's generated by using the FIDO2 API client. Then you launch it with the intent key. And everything is done behind the scene. I mean, at least developer wouldn't care about it. So after this, internal activity is generated, then UI is displayed by the system, and when user attaches biometric sensor, registration, generation, and store of that key is all done behind the scene. And when everything is done, the internal system returns the result. It's done in on activity result. So when you receive the intent in on activity result, you just need to specify this key, fido.fido2 key response extra, to retrieve the data. That data is the class called Authenticator Attestation Response. This response is mapped to this spec, well, server Authenticator Attestation Response, defined in the FIDO2 spec, which has two values, client data JSON and attestation object. Client data JSON is basically the JSON encoded data passed from the client. So it includes like challenge and the origin of a relying party sent to you. Again, you don't need to actually define the client data JSON by yourself. Only you need to do is just call the field of the data you extracted from the intent. And then you, yeah, that's what you need to. And the other field called the attestation object. This contains credential information. That includes the public key being generated in the authenticator and the ID provided to that credential. Also, it has authentication information, but the one big thing is that the signature. What do I mean by signature? So it is a signature made over the client data JSON and other data by the attestation key. That means client data JSON is signed and then a signature is made. And when you send that response to server receives both signed credential information and raw client data JSON. So server side can undergo the cryptographic, the signature verification on the server side, which means server side can verify the attestation process. Okay, so that was registration or attestation. Let's move on to assertion process. Well, assertion process is again very similar to attestation. First, you go get options to server, call the internal system. Well, in this case, you do not generate the credential, but more like retrieving the credential. And then send that result to the server. 3 steps. So when you make a request, it's much simpler than assertion. This seems very self-explanatory, but basically this request declares, okay, this guy is going to make an authentication process to our service by providing the username and then whether the service wants to make a user verification or not. After you receive the response to that option, you then want to retrieve the credential to authenticate users. And that option has this interface called credential get option response. Again, the FIDO2 provides a nice blueprints already called public key credential request options. So you call the builder, you put a bunch of parameters, and then call the client again. So again, you need to set the challenge so server side can check the challenge and can undergo the challenge and response verification. And timeouts sound how long you want that authentication to last, and RPID. This allow list is kind of similar to exclusion list in terms of it's a list of credential, but in this case it is saying you're whitelisting which credential can be used. So if server wants like specific credential, it can set the unique credential ID and send back as an option, which will be like an allow list. And last parameter is called extension. Well, this is okay by name. It says extension and can be defined very widely manner, so I won't go over it. But you can define your unique credential information over here. The one thing that was not introduced in the FIDO is user verification requirement field. This field is whether you want authenticator to verify the user is actually user, like by biometric. And this field does not exist in the FIDO2 package. I don't know, it means Android is not interested in it at all, or it's assuming it has user verification by default. I'm not sure because I couldn't test it. Okay. And then option is made, and you call the you launch internal activity by using FIDO2 API client and its intent. And again, after this, everything is done behind the scene. The internal system retrieves the will present the UI for users to undergo the biometric verification or YubiKey verification and verify that user. And when that's done, the result is sent back to activity result once again. You can retrieve the data as usual way, but specifying the key as FIDO2 key response extra, just like assertion. In this case, the data type is going to authenticator assertion response, which comprises now 4 fields. The first one, the client data JSON, is what you already seen from the attestation. Authenticator data is a bit new idea, but it's basically is a data of authenticator. Data generated within the authenticator. So it contains a configuration of authenticators, like does it require the user verification, and what RP relying party is meant to be tied with that credential. And then credential, the public key itself is contained in this authenticator data. Then this is a signature. Just like assertion, this signature is this signature produced from client data JSON. In this case, the key which signs this client data JSON is the private key generated by user. That means assertion public key, not the attestation public key. So this is the way it does. So it concatenates the authenticator data and the client data together, and assertion private key signs over it and produce this signature. So when you send that signature over server, again, the server can then do the usual cryptographical operation to verify that signature is indeed signed. When you decrypt the signature by public key, you can compare it if it's a concatenation of client data JSON authenticator data. So you can check the data integrity for it. Okay, and that's pretty much it for basic implementation of the FIDO2 packages in Android. So what we have covered is, again, overview of FIDO, implementation of FIDO2 in Android. And I hope you get the idea of using the packages to achieve FIDO2 authenticator. And from now on, this is just my opinion on like what we need to care about FIDO2 as an Android developer. So the first thing I want to express is that we should avoid reinventing the wheel thing, because package is already there, right? You don't want to generate the UI by yourself. You don't want to make another method to generate a key and store it in the safe manner. You don't really want to do that, right? And so instead, you should focus on understanding each parameters, and by combining those parameters, what happens to the FIDO2 packages. I think you should focus on there. And also, you should really care how you communicate with other departments, because by making your authentication system to FIDO specific stuff, that means you are going to throw some convenient part of password authentication. So for example, if user lost their credential password, at this age, we can just reset the password for users, behalf of users, but you cannot do that, and you can no longer reset the credential for users because credential is stored in the user's device. So you should cooperate with CS, customer service, in case of device loss, and there should be other operation you should be care of. So that's what you should do in terms of FIDO2. So the conclusion is FIDO2 may solve the current pain, the password-centric authentication. And Android or Google already prepared a nice package for you. So go try understand that package more rather than implementing by yourself. And also be prepared to inconvenient situation, but because the password get lost, the password-centric authentication is no longer there. So that's my conclusion. And thank you for your patience, and I hope you have a nice authentication experience from now on. I will be in the exhibition room and doing office hours, so please come and stop by. Also, I had a very difficult time researching these things because FIDO2 package is actually limited to only some developers, and I myself, the personal developer, cannot really investigate the actual behavior of it. So if you know the how to unlock it or actual behavior, please give me an advice. Okay, that's it. Thank you.